Hi everyone, I'm Jasur Bek Nimatulayev and today I'm excited to walk you through my presentation on probability. Probability is a fascinating topic that's not only foundational to math but also powers many aspects of our modern world. Let's dive in. First, let's look at the structure of my presentation. We will cover the history of probability, its fundamentals, a simple example, and its real-world applications. This roadmap will help us understand why probability matters and how it's used today. Let's start with a brief history of probability. The story begins in the 17th century when the two French mathematicians Pierre de Fermat and Blaise Pascal started exchanging letters about gambling problem called problem of points. They want to figure out how to fairly divide the winnings in an unfinished game of chance. Their ideas laid the groundwork for probability theory. Fast forward to the 18th century, Thomas Bayes introduced Bayes' theorem, which revolutionized how we update predictions with new evidence. These early thinkers turned uncertainty into science, and their work still shapes how we analyze risks and make decisions today. So, why does probability matter? It's the backbone of machine learning, helping algorithms make predictions. It's critical in data science for analyzing trends, and it guides decisions in uncertain situations. You see probability in weather forecasts, in finance for risk assessment, and in medicine for diagnosis, and even in research engines and recommendation systems like Netflix. Probability is everywhere, shaping how we interact with technology and make choices. Now let's get to the fundamentals. Probability starts with the sample space, which is all possible outcomes of an event, like flipping a coin gives you heads or tails. An event is the specific outcome we care about, like getting heads. There are three key axioms. The probability of any event is never negative. The second one is the probability of the entire sample space is 1, and for mutually exclusive events, those that cannot happen together. The probability of either happening is the sum of their individual probabilities, and these rules form the foundation of how we can calculate probabilities. Now let's talk about conditional probability and Bayes' theorem. Thomas Bayes is a mathematician who lived in 18th century. Imagine you are trying to figure out the chance of something happening, but you get new information that changes your perspective. Bayes' theorem helps you update the chance. For example, say you want to know the probability of event A happening, given that event B has occurred. The formula is probability of A given B is equal to probability of B given A multiplied by probability A divided by probability B. In simple terms, it's like saying take your initial guess about A. Adjust it based on how likely B is when A happens, and scale it by how common B is overall. This is super useful in things like medical testing, where new test results refine a diagnosis, or in spam filters that learn from new emails. Next, let's try a quick example to make the probability concrete. Imagine a bag with 5 marbles, 4 blue and 1 red. What's the probability of picking a blue marble? To find this, we need to compare how many blue marbles there are to the total number of marbles. There are 4 marbles that could be picked and 5 marbles in total. So the probability of picking blue marble is 4 out of 5, which we write as 4 divided by 5. We can also express this as a decimal. 4 divided by 5 is equal to 0.8, or as a percentage, 80%. This means if you pick a marble randomly, you have an 80% chance of getting a blue one. That's pretty likely, isn't it? But remember, there is still a 1 in 5 chance you might get the red marble instead. Now, let's explore some applications. In machine learning, probability drives classification algorithms like naive Bayes for spam email detection and helps quantify uncertainty in predictions. In risk assessment, it's used for financial modeling, calculating insurance premiums, or optimizing investment portfolios. In cryptography, probability ensures secure encryption through random key generation and support blockchain security. And in everyday life, probability is behind weather forecasts, recommendation systems, GPS navigations, lotteries, and medical diagnosis, and so on. In a nutshell, here are the key takeaways. Probability provides a framework for dealing with uncertainty, often challenging our intuition. It's a driving force in modern computing and artificial intelligence, and understanding it sharpens our decision making. And this is a reference list that I used for preparing this presentation. Thank you for your attention. I hope this presentation gave you a clear picture of why probability is so powerful and how it shapes our world.